Hi everyone, this is Pure Maths and we are looking at intersection of straight lines and circles. There were two problems. First one is already been solved in a previous video. Now we are looking at question number 2. We're moving straight away to this question. The question says, show that the line x plus y equals 11 meets the circle with equation x squared plus y minus 3 squared equals 32 at only one point. They want you to show that this line meets this equation at only one point. So if this is our circle, so we want to show it's this line x plus y. This is the circle, you see. So this is our line, x plus y equals to 11, meets this circle at only one point. It must be a tangent then. This line must be a tangent to this circle. So let's look at this problem. It gives us, the second part says find the coordinates of the point of intersection. That is, now we've got to find the point where the circle and that line meet. Now what the second problem is telling us. But let's look at part A of the question. We have a line and we have a circle. And we are to show that the line meets the circle at only one point. So if you look at the line, the equation of the line, it has two unknowns. You look at the equation of the circle, it's two unknowns as well. So what does this tell us? This is telling us it's something like a simultaneous equation. We're going to solve this problem using the idea we have from solving problems of simultaneous equations. Two unknowns, two functions. Now, first equation says x plus y equals 11. The second one says x squared plus y minus 3 all squared equals 32. We got x squared already here. We want x inside this bracket so that it will be just one unknown. Then it's easy for us to solve the problem. So since we want to put x here, so we have to make y the subject of the formula from this first equation. So this first equation will now give us y equals 11 minus x. Y equals 11 minus x. So wherever we see y, we put 11 minus x. We come now to the second equation. X squared plus y, we say y equals 11 minus x. 11 minus x. We have 3 minus 3 all squared equals 32. This is y minus 3 because y is 11 minus x. Now, what do you have here? 11 minus x squared plus 11 minus 3. This will give us 8 minus x all squared equals 32. Because 11 minus 3, you get 8. So what do we do next? This is now a quadratic equation which can be solved quite easily with so many quadratic equation methods to use. But let's expand it first and see what we get. If we expand this, you get x squared. We are now expanding this. I hope you know how to do that. Plus 64 minus twice their products minus x times 8 is 8x twice their products, so 16x minus 16x, then plus x squared equals 32. This is what you get. So x, you get 2x squared, x squared plus x squared, you get 2x squared minus 16x. You now have 64 here, If we bring this one over the equality sign, it's going to be 64 minus 32 because it's plus here. So 64 minus 32, you get plus, because this is bigger. 32 equals, there is nothing left. We already brought it over there, 0. Can we further do something? Yes, we see that 2 is a factor. So we can divide everything by 2. We divide 2 throughout the equation. We divide, even 0, we divide this by 2. So this one is going to give you x squared minus 8x plus 16 equals 0. 0 over 2 is 0. That's all we've done. So we now have this simple equation which we can easily factorize. What are the factors of 16? 4. 4 times 4, 16. I know 2 times 8, 16. But 4 times 4, because 4 times 4 will give you 16. And if we add minus 4, correct, we'll have 16 here. And we'll have minus 8 there. This one will add, this one will multiply. If we choose 4, minus 4 times minus 4, this will give us 16. But if we add minus 4 plus minus 4, this will give us minus 8. So the factors are 4 and 4. Therefore, we have x minus 4 and x minus 4 equals 0. So this is x equals to 4 twice. X equals to 4 twice for this equation. Yeah? Factor x. So now, but they ask you to show that this line meets the circle in this equation at only one point. Yes, got only 4 here. Not two numbers, it's just 1. But how do you show that? When you are solving quadratic equations and you use the formula method tells us that x is equals to minus b plus or minus the square root of b squared minus 4ac b squared all over 2a. This will give you the solution of any quadratic equation. If you don't want to factorize, if you find factorization is difficult for you, this is the formula method. This gives you the solution of any quadratic equation problem. You solve it with this. But sometimes it's much easier to factorize. You can easily see the factors of numbers. You can easily factorize and you get your answer as quickly as possible. But if you can't factorize, then this gives you the roots of any quadratic equation, this formula. So now you have this. But what is very important here is what is inside this square root sign. B squared minus 4ac. This is what is called the discriminant of a quadratic equation, or of quadratic equations in general. What you have here, if what is inside this square root sign is greater than 0, in other words, if b squared is greater than 4ac, the answer you get is you will get two distinct real roots. You will get 2 roots of the equation that are real and distinct, different. What if b squared minus 4ac is less than 0? This one you get two distinct real roots. This one, if b squared minus 4ac is less than 0, you get imaginary roots. Imaginary roots. What if b squared minus 4ac is equal to 0? we get one real root. So since they ask us to show that this line meets the circle at only one point, so this is what we need to state, because this will give you only one root. That's what we have here. It's only one root. It's